So thank you very much, and it's lovely to be here and to talk about a subject that's close to my heart, which is data and the subsurface. So I've started off with this image because, of course, everything that you build on, the ground is supporting it and the ground is impacting it. So we're going to talk a little bit about the built environment. I'm not ashamed to say that it's going to have a lot about subsurface, but I will try and link it back to the built environment and housing so that you can see where it all fits in. So the first thing is, what is the digital environment? And it's much more than just the novel use of data and sensors. Yes, that's great, and we can stream real-time data, and it's really fantastic. But what it's doing is it's transforming how information is shared. So when we're talking about digital transformation and the fourth industrial revolution, it's about how information is shared and how people engage with that information in the world around them, as in your iPads, your iPhones, how you interact with that virtual environment. And it's changing the process of scientific discovery as well as business operations. So it's changing how my staff do their research and how we are making our products and services. And I wanted to bring it back to something that's been happening recently. And this actual picture of a flood was 2007. And from my local area, from the Midlands, to really highlight to you how critical understanding ground conditions is. And we've talked about resilience earlier, first thing this morning. And this shows you how we actually have a huge amount of critical infrastructure intersecting in one place in the East Midlands, and how one flood can knock the whole thing out. This also serves the second biggest freight airport in the UK, which is East Midlands Airport. Outside Heathrow, this is the one bringing goods and services into the country. And yet, if we get major floods, we can't do anything about it. So the ground conditions and understanding the natural hazards around those ground conditions is really important. BGS is custodians of massive amounts of information and data, as you can see here. Okay, and we've had a revolution since I've been working at the survey. We've gone from, and I started out as a mapping geologist with a pencil colouring everything in, and I'm not even that old, you know. We converted that to digital, and now we are producing mathematical and conceptual models in 4D. So we're bringing in time elements to understand how the ground is changing with the impacts of climate change over time. The first thing we did when we started doing this was we looked at subsidence risk. We produced a set of data, and you can see here swell shrink clays, landslides, compressible potential, and there's solution potential there. And we produced them all as maps because a geological map is very good for geologists. It is super rubbish for anybody that's not a geologist, okay? And when we worked out that only 0.02% of the population understood what we were talking about, we started developing these sort of things. And then it's led into this revolution of having massive amounts of data out there. So nowadays, we don't just use our own data, we are adding together lots of different data. So, for example, you've got a type of landslide called debris flow, very important in Scotland. They have a lot of these problems. We worked with the Met Office on this project, and we worked out that slopes on a southwest-facing direction, that's where most of the bad weather was coming from. And when we highlighted where all the debris flow potentials were, we could start to forecast the risk. We could start to understand the risk and help transport for Scotland really start to understand that. We then took geoshore and we looked at the swell shrink potential, and we looked at the COP19 data, and we've added the climate change data to that, and now we can look at where in the country that risk of swell shrink is going to get worse, and where in the country it might conversely get better. Unfortunately, it mostly gets worse, but you know, it's really useful for building because it will change on the times of depth of foundations that you actually start to need. And there's lots of other things up there that we've been doing as well. One example that I thought I'd highlight is river scour. So river scour is really important for bridge stability because it knocks down lots of bridges. It also, and bridges carry most of your infrastructure across from one area to another. So it cuts off towns and villages very, very quickly, not just through transportation, but through your telephone lines, through your gas and electricities. We could do this project because we were using the huge amount of open data that's out there now. And this is the other thing, use the data that's out there, really look at the different data, and your data is really important, but it's even more important if you mash it together with lots of other people's data. But when you're looking at working to define solutions, so I've said, okay, nobody can understand a geological map except geologists. But what we've got to go back to a point that was made in, I think, the second talk today, was about that you have to co-design those solutions. You have to understand what the problem is that the people have, that you're trying to solve that problem. As a scientist, we tend to be very, very good at providing solutions to problems no one knew they had. So we have to look at our innovation in a very different way. And one of the reasons I'm highlighting this project is because we did it in a very different way. We had secondments. We actually worked in with Historic England and the Environment Agency to try and understand what their problems were. And then we produced a whole set of products and services around that problem for them, some of which are free, some of which are premium services. But the point of this is we've designed it with the user in mind. We haven't come together with a solution that actually can't be used. The other thing that we're doing more and more of, and again, very topical, flooding. So flood risk, as well as it being caused by rain, the reason that we often get flood risk that lasts for a very long time is because it's also partly due to groundwater. So once you get lots of rain, the groundwater subsurface rises, and once that hits the surface, it can last for quite a long time and cause a lot of long-term damage. It doesn't run away like pluvial flooding will. So we've been working with a company called Ambiental to help them piece together an understanding of how we can understand the risk of groundwater and surface water flooding. So how can we combine that and have a whole system approach to trying to help people understand that risk? Now, of course, we could say, as the Environment Agency have been saying in a very measured way this morning on Radio 4, you know, please don't build in floodplains. But the Environment Agency and us understand that there are some situations where there is no alternative other than to build in those floodplains. So we have to be able to understand the risk and we have to be able to mitigate that risk. It's not going to go away. It's a natural thing. So the other things that we can start to do, if you're starting to mash lots of data together, you can start to do all sorts of really interesting things. So I thought I'd put this up. This is just an idea of a colleague of mine someone came in fact, I think it was National Grid. They've got an issue with tree fall. Now, I'm sure that there's lots of homeowners that also have issues with tree fall as well. So how can geology data, which doesn't seem to have anything to do with trees, actually start to help you to predict where tree fall might happen? And it means, and the reality is that geology affects the soil affects the stability of trees, and we can start to forewarn landowners, if we actually went ahead and produced this is actually just an idea at the moment, of trying to bring things together within our environment to provide better understandings of it and better infrastructure management. So I want to talk now in a little bit of a different tack about fair data. So within the science community particularly, and I think within the geospatial community as a whole, we're talking a lot at the moment about fair data. So fair data is data that is findable, it's accessible, it's interoperable, and it's reusable. And it's not an easy thing to do. It's actually quite a difficult thing to do. It's quite easy to make your data findable, but to make it interoperable is quite difficult, and to make it reusable is also quite hard because we don't know how people are going to use our data. We don't know what formats that data needs to be in. The most important thing is we do need to describe data much better. So metadata becomes really, really important in describing what that data is. And that means that when you make your data open, and we're very proud that we've just had 10 years of our open geoscience, which is where all our open and free data is. When you make it open, and you've followed the FAIR principles, you are then getting data that is actually usable, that is actually making a difference. And I'm going to take one example. And that example is with the infrastructure sector. And this is about sharing ground investigation data. They drill lots and lots of holes. They have 50% of their projects are delayed because they don't understand the ground conditions that they're building in. But there's lots of borehole data that hasn't been shared that could have supported them and could have helped them. So we've got together, and this is one example, we have another project on a similar line with Glasgow City Council. So we've got together with a whole group of organisations from the community, worked with the community and said, right, well, if you're all using an AGS format, which is a standard format to transfer information with boreholes, why don't you share that information? And we will provide it to you for free back to you. So you give us the better information, we can improve our geological models as well, and you can get access to that information for free. And we've managed to release an extra 10,000 borehole records. I think it's actually close to up to 40,000 now because the project's been going a little while. But the power of that data, the power of being able to offer people a way of interacting with that data once they gave it to us has really increased the use of that information. We used to charge for borehole information. We don't anymore, and actually the interaction and the use of that data has gone up about 100-fold. So it's really positive. So another project is about so how do we integrate subsurface data now with the surface data, with where you're doing the building? And one of the projects that we've been looking at is Project Iceberg. And really what we're looking here is how do we digitise the subsurface data, connect it in, enhance asset management, and increase profitability, it's suggested by 20 to 30%. So this project's ongoing. It's working. It's been brought into the Geospatial Commission now, so we're working with Cabinet Office on this and trying to integrate together and linking data together in a much more seamless and easy way so that it's easy to use our information and data holdings. The other thing is about using that data and trying to get people to use their environment better. So rather than everyone always going about building on greenfield sites, what we'd really like people to do is start to build on brownfield sites. And this tool was, again, it's co-designed with Greater Manchester Authority to understand not only the ground risks, which you've got on this side, but also the cost of the remediation of that ground. And this was a fantastic pilot study that's been incredibly successful, and we're going to be sort of trying to push that out to other authorities have asked for us to do the same thing for them. So it's a way from just looking at the ground as a geologist, but really pushing it towards understanding people's problems. Manchester has a problem with large amounts of brownfield land that isn't being used. It also has a housing problem. How can you combine those two together? The other thing we've been doing is looking at how we put the subsurface into BIM. And this is another project that was done with a group of people. So again, when we're working with other organisations, it's about understanding what their problems are and enabling people to be able to use our data in a form that they want to use it in the systems that they want to use it in. So to conclude, And that's very much a whistle-stop tour of some of the things that we're working on and what we're doing. There is a huge potential in the reuse of data and information. It's massive, not only for me to be reusing your information into my research and understanding, but for you to be using my information. But we have to make our data fair, and we have to invest in doing that and put resources to that. Data mashing, so this is where we're putting together lots of different types of data, is providing new insights and new ways of using environmental data, and is a real drive forward. Machine learning, AI, all of those things are basically using data mashing together to get new insights out of data. But what I hope I've also tried to show you is that digital innovation is about people. It's about co-designing your solutions and understanding the problem that your user has. Now, I always take that someone said to me, when you're looking at innovation, you need to be really careful about what people are asking you. So if you're talking to someone and they say, well, I want a better hairdryer, why do they want a better hairdryer? Do they want to get the hair dry faster? If they want to get the hair dry faster, they don't necessarily need a hairdryer to do that. And that's innovation, but it's understanding the problem first. Thank you very much.